So okay, so hari ni, so today, okay, kita nak tengok applications of Laplace transform in electrical circuit system. Okay, how we are going to analyze and solve the EC problem using Laplace transform. Okay, so for this topic, okay, I only concentrate on how you want to transform from a circuit from T domain to frequency domain or S domain. Okay. So actually there's 3 steps that you have to follow. Okay. So first you have to change, okay, the signal. Okay, you have a signal in time domain. Okay, in time domain T. Okay, you have to change it to frequency domain. Okay, in S, which means you will use the Laplace transform to transform from T to S. Okay, and then the second step is, okay, you will analyze this circuit, okay, using either KVL or KVL or KCL, Kirchhoff voltage law or Kirchhoff current law. Okay, I'm sure you know what is KVL, what is KCL. KVL is you have a loop. Okay, let's say you have this. Okay. Okay, so this is KVL. Okay, you have V in, you have R1, R2. So KVL is the total voltage inside here is V1 plus V2 equals to V in. Right, this is KVL. And KCL is, okay, you have here is I1, this one is I2, this one is I3. Okay, therefore I1 equals to I2 plus I3. Right? Betul ke salah? Saya tak tahu ni, you all dah belajar ini. Betul
Betul,
Correct me if I'm wrong, okay? Okay, saya belajar isi ni masa tahun bila saya belajar tahun 2 sem 1 di UTM, which is tahun 2000. Now 2021. Okay. Okay. Ada soalan tak? Yang ini? Tak ada. Okay, tak ada. Okay, step ketiga. Okay, first you convert from time domain to S domain to frequency domain, and then you analyze using KVL or KCL. Okay. And the third one, last one is you convert back to S, from S for frequency domain to time domain using inverse Laplace transform. Okay, first you use Laplace transform to transform from time to S, and then you do the KVL, KCL or whatever here, and then you convert back to time domain. Okay, you convert back is either you want to get the IT or VT. Okay. Okay. So kita tengok how we transform the circuit to frequency domain. Okay. Let's say you have the, macam mana saya nak buat ni? Okay, so here you have time domain. So here you have S domain or frequency domain. Okay, let's say you have the resistor R.
Madam, ada
Yes,
orang
saya.
nak masuk.
Ada orang nak masuk.
Uh-uh.
Okay, dah masuk belum? Oh, ramai. Okay. Dah Dah ke?
Jap. Dah.
Okay. Okay. So you have a circuit in time domain. Okay. So this one is a VRT. So what is VRT? VRT is equals to, here you have I, T, right? Betul? So Ohm's law is V equals to IR, right? Voltage equals to current times with resistor. Okay. So here VRT equals to IT times with R. Right. Betul? Betul ke?
Betul.
Betul eh? Okay.
Betul.
Okay. So we want to convert from T to S here. So we have here VRT equals to ITR. Okay, so we are using a Laplace. So kita Laplacekan semua. Okay. Okay. And R, okay. Kita keluarkan R dekat luar. So R, I, T. Okay. So you Laplace a VRT, you will get VRS, right? Equals to R, I, S. Okay. Okay. Faham?
Faham doktor?
Faham eh? Okay. So now we move to. Okay. Next, you have a inductor. L. Okay. So this is in time domain. Okay. So you have L. Okay. So L, you have the V L T equals to L D I T over D T. Right. Okay. This is how you want to get the voltage for inductor here. You have to differentiate the current. Okay. So now we want to transform this. Charge. Transform this time domain signal to frequency domain signal. Okay. So here you have a VLT. Yeah. Okay. So equals to, you Laplace here also L DIT over DT. Okay. So this L kita keluarkan. Now you have L. Okay. And then you Laplace I DIT over DT. Okay. Okay. So you Laplace VLT, you will get VLS. Okay. Equals to L. Okay. So if you differentiate DIT over DT, kalau you tengok dekat, macam mana? Nanti. Lambat pula. Okay. Okay, so kalau you tengok dekat table ni, okay, Y prime T, okay, Y prime T is a dy over dt. Okay, so sama untuk case ni, okay, ini adalah I prime T. Okay, So when we want to transform this I prime, okay, it will be S I S minus I 0. Okay. So here is dit over dt. You Laplace, you will get S I S minus I 0. Okay. In this case, okay, for the circuit, okay, we have a I minus, or it's either I minus or B 0 minus. Okay, it's the initial condition. This one for the conductor, this one for inductor. Okay, this one for inductor, this one for capacitor. Okay. Okay, so equals to LSIS minus LI 0 minus. Okay. Okay, if you transform this one in circuit, okay, it will be, you have inductor here with the initial condition here. Okay, so you have here LSIS, and this one is minus LI. Okay, you have minus here, right? So this one also minus. Okay, any question? Tak ada. Okay, so this one for inductor, and now we go to capacitor. Okay. Okay, for capacitor, you have the capacitor here. Okay, C. Okay, so for C, you will get IT here. IT equals to C. Okay, D, you differentiate voltage. Okay, then you get current. Okay. Okay, ini you all dah belajar kan dalam isi kan? Dah ke belum?
Dah.
Dah kan? Dah kan? So you all dah expert sangat dah kan benda ni kan? Alright. Okay. So now the signal is in time domain. Okay. We want to change it to frequency domain. So we have to Laplace this one. Okay. So you Laplace this side also. Okay. Okay, macam biasa, C you bring to the outside here, C, and then Laplace dVt over dt. Okay, so what you get if you Laplace IT, you will get IS equals to C. Okay, and you Laplace dVt over dt, you will get S Vs minus V0. Okay, so CSVS minus CV0. Okay. Okay. Okay, then you rearrange this one. Okay. So you have a CSVS equals to IS plus with CV. Okay. Right. You bring this one to this side, so it will be plus CVO. Okay. Then VS. Okay. IS divided by CS plus CV. CV. Okay, this C and C cancel. Okay, so you have a VS equals to IS over CS plus with V over S. Okay. And the equivalent circuit will be okay. So this is your IS over CS, and this one is a V over S. Okay. Any question?
Doktor,
Ada soalan?
nak
Yes,
tengok ke
saya.
atas kejap, Doktor?
Atas mana? Here?
Atas lagi, Doktor.
Atas lagi.
Okey.
Okay. Dah?
Okey, Doktor.
Okay. This one dah.
Sudah, Doktor.
Okay.
Okey, Doktor.
Okay. So now kita tengok dia punya example Okay. Okay. They give you the initial voltage 10 volt. Okay. And the question is for the RC circuit, okay, solve for, so you have to solve for current, okay, and voltage. Okay, using Laplace transform. Okay. So you have to, apa you nak buat? You change this circuit into the equivalent frequency domain circuit. Okay, so what you have here you have a capacitor. Okay, so for capacitor, we know that for capacitor, the circuit will be like this, right? You have a C, and then you have the voltage here. Okay, and then here you have the resistor. Okay, it will be like this. So what is the value is, okay, for R, okay, we know that, okay, so VR T equals to IT times R. If you change to VS, okay, it will be ISRS. Okay, ISR. Okay, so what is the value of R? Is a 4. So 4 IS. Okay, so here is 4 IS. And how about here? Okay, so dekat sini, we know that dekat sini tadi kita dah buatkan yang ni kan. Okay, so VS equals to IS over CS plus V naught minus over VS. Okay, so here VS equals to IS divided by CS plus with V naught minus divided by S. Okay, so what is C? C is 0.2. So 1 over 0.2 you will get apa dia? 1 bagi 0.2. 2. 1 bagi 0.2 berapa?
5.
5.
Hmm?
5.
5. So, plus V not minus, okay. Dia dah bagi V not minus kan? 10. So, 10 per S. Okay. So, here is 10 over S and here is 5 over S I S. Okay. So, this is how you transform from time domain signal to frequency domain dekat sini.
Doktor, tadi 5 tu dapat macam mana, doktor?
5. Okay, 5 is, okay, you gantikan C, nilai C, this is nilai C, 0.2 farad. So you replace here 0.2, so 1 over 0.2, you will get 5. Okay. So make
Okay,
sure in your final, okay, if there is any question, okay, regarding circuit, okay, so make sure you transform from this circuit to this circuit first. Okay, then then you can make the analysis. It's either KVL or KCL. Okay, so this case we will use a KVL. Okay, there is a loop here. Okay, so you buat KVL. Betul? So what is a KVL here is, apa KVL dia kat sini? So you have the
negative 10 over S.
okay, you have a negative
10 over
10
S
over S
plus
plus
5 over S
5
IS
over S I S plus
plus 4 IS equal to 0.
okay. Faham semua macam mana nak buat KVL? Okay. Okay, then you satukan IS. Right, you kumpulkan IS. Okay. So you will have 5 over S plus 4 equals to this one, you bring to this side. So it will be 10 over S. Right. Okay. Okay. Then IS. Okay, this one you bring to this side juga equals to 10 per S. Sepuluh per S, you divide with this one. Okay. 5 over S plus 4. Okay. Okay, so cuba pemudahkan 10 per S bahagi ni. Tak boleh. Kita nak apa pun. Tak roti nanti kejap. Okay, so macam mana? 10 per S. Okay, this one.
Darab
Darab
S over 5.
S over 5 plus 4 S.
Yep.
Betul? Kan? This one kan? Okay, so S and S here cancel. So you have here 10 over 4S plus 5. Okay. Always remember that kalau you nak solvekan any Laplace transform or Fourier transform, this S kena betul-betul single S sahaja. Okay. Then you faktor keluarkan ni, you akan dapat 10 per 4 S plus 5/4. Right. Betul? Betul?
Betul, Doktor.
Okay, betul. Okay, then ini kita boleh simplify, right? So this one will be 5, this one 4. Okay, so you have here, sorry, kenapa 4 pula
Doktor.
2. Sorry So 2. So you will have 5/2 divided by S plus 5/4. Okay. Okay. Okay, so now, okay, from here kita
Doktor,
ada IS kan? Ya saya?
yang dalam bracket tu S plus 5/4 kan?
Ha.
Yang tu 4 ke 2, Doktor?
Yang mana?
Yang
Ini.
atas.
Yang ni 2.
Atas lagi, Doktor.
Ini atas lagi ni.
Ya. So S
Ini
plus
2.
5/4 kan?
Ha.
Yang over 4 tu 4 ke atau 2?
Sekejap Yang mana? Ni.
Ah,
Yang ni 4. 4 dah. This 4, okay. Daripada sini, you faktor keluarkan 4 ni. Okay. So bila
okay.
you faktor keluar, you akan dapat S, okay, plus 5/4. Ini 4 yang kita keluarkan. Okay, this 4 kita simplify dengan 10 ke atas ni. Okay. So 10 dengan 4 is actually 5/2. So that's why you get 5/2 dekat sini. Okay.
Okay, Doktor.
Okay. Okay. So now we can get IT from here. Okay. Okay, you find the inverse for IS and also you find the inverse for this one. Okay. So this 5/2 kita keluarkan. Okay. So you have here is 5/2. Okay. And then you find the inverse for 1/s plus 5/4. Okay. And we know that inverse for IS is IT. Okay. So IT equals to 5/2. Okay. So inverse for 1/s plus 5/4. Okay, kita refer dekat this table. Okay, you tengok table ni. 1/s minus A. Here you have 1/s plus A. Okay, so S plus A and here S minus A. If S minus A, your answer will be exponent AT. If S plus A, it will be exponent minus AT, right? Betul? Here. Okay, so your answer will be exponent minus
Negative 5/4
5/4 T.
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 Okay, okay, and okay, you have 2 times with HT. Okay, so you know what is a HT? HT is a unit step function. Unit step function which means you times with this one. This is a HT. In a ODE, we note as a HT. Okay, but next semester, when you learn, okay, you take the signal and system, you will use a UT. It's the same thing. Okay, if you use HT or UT, which means your signal start from 0. You will start from 0. If you times your signal with HT or UT. Okay. Okay. So this will be your IT. Okay. Ada soalan tak? Any question regarding this IT? Tak ada. Okay. Kalau tak ada, kita tengok how to get the VT. Okay, because the question asks you to solve for current and voltage. Okay, so now, okay, for VT. Okay, so
Doktor,
for
ada
V,
pelajar masuk kelas, doktor.
okay. Mana? Dah masuk belum? Okay, so now you want to find VT. Okay. Okay, so yang tadi ni, kita tengok dekat sini. Okay, we will use this. Belum masuk Dah masuk belum? Okay, so we will use this equation to find voltage. Okay. Okay. Apa equation dia tadi? Vs, okay. Is over Cs. Okay. So Vs, okay, equals to Is over Cs minus plus okay. Mama boleh. Okay, so Is, okay, we already get it from here. So this is a Is that we are going to use. Okay. So Is is 5 over 2, okay, S plus 5 over 4 divide by CS.
Five.
CS
Bukan
CS
5 kalau ada.
0.2S, right? Okay. Plus with V naught minus is given as 10. Okay. So you plus with 10 over S. Okay, and 0.2S berapa nilai dia?
5 kan tadi.
5. So it will be 1 over 5, right? 5 over 2 S plus 5 over 4 divided by S over 5, right? Okay, plus with 10 over S. Okay, so simplify this. Ya, saya.
Yang S over 5 tu macam mana?
S over 5. Alamak, siapa sampai?
Tadi kita dapat 5 over S kan, doktor?
Kejap Okay, ini kan 0.5S kan daripada sini. So, ambil duit mama kat situ. Okay, so 0.2 S. 0.2 S ikut awak. So daripada sini, betul kan?
Bukan 1 over 0.2 equal 5.
Bukan. Ni. C kita adalah 0.2. So here 0.2 darabkan dengan S. So you ada 0.2 S.
Tapi doktor, masa kita buat dekat atas untuk circuit,
Kat sini Kat mana? Kat
Atas
sini.
lagi. Atas lagi madam. Ya,
5 over
sini.
S betul.
Okay. Dia macam ni. Okay, dia yang atas ni. Yang ini. Okay. You ada 1 per CS. Betul tak? 1 per CS kan? Betul? So, equals to 1 per 0.5. 0.5 pula. C kita adalah 0.2. So, 0.2 S. Okay. 0.2 S adalah sama juga dengan 1 per S per 5. Okay. So, kalau you simplify this one, okay, dia adalah sama dengan 5 over S. Right. Betul tak?
Betul.
Okay. Okay. So, yang ini adalah S over 5. Okay. Okay. So, kita simplify this one. Okay. Awak simplify because kat sini dia dah ada berlayer-layer. Okay. So, 5 over 2. Okay. Divide by S plus 5 over 4 times with 5 over S.
Betul.
Okay. So you will get 5 kali 5. Nak apa?
Apa guna?
So 5 kali 5, 25. Okay. So this one times dengan this one. Okay, ini 25 per 5 per 5 pula per 2. Okay. 25 divide by 2 here. Okay. And this one is S plus 5 over 4. Okay. Ataupun 2 ni you boleh turun ke bawah. So 25 over 2S plus 5 over 4. Okay. Ini baru yang kat sini you belum plus dengan 10 over S lagi. Okay. So VS equals to 25 over 2S plus 5 over 4 plus with 10 over S. Okay. So to find VT, you have to use the inverse Laplace transform. Okay. So inverse for VS. Okay. And then inverse for okay. Okay, so inverse for VS is VT. Oh sorry, tak ada kurungan.
Hakim, mama kelas Hakim.
Okay. Then inverse for 25 over 2SS plus 5 over 4. Okay, so this one, okay, you have to use a partial fraction ataupun pecahan separa. Okay. So you have here 25 over 2S plus 5 over 4. Okay, so pecahan separanya adalah A over 2S plus B S plus 5 over 4. Okay. Then A S plus 5 over 4 plus with B times 2S equals to 25. Okay. If S equals betul? 20. If S equals to minus 5 over 4, okay, A equals to 0 because this one minus this one 0. Okay, and B equals to minus 5 over 4 times 2B. This one is equals to 25 and B equals to 25 times with minus 2 over 5 plus 10. Okay,
Doktor nak
faham
tengok
eh?
dekat tu sekejap.
Tengah kelas kan? Tengah.
Okey doktor.
Okay, okay. So A is A is 20. So kita masuk balik kat sini. Okay, so you have a Laplace for 20 over 2S. Okay, and then minus, okay, inverse So inverse, this one is 10 over S plus 5 over 4. Okay, and then inverse for 10 over S. Okay. Okay. So inverse for this one kita boleh pemudahkan kan. So this one 10 over S. So inverse for 10 over S is actually you refer dekat table. Okay, A over S, so be A. So this one will be
10.
10. Okay. This one also 10, right? Sama kan? Plus with 10. Okay, minus with this one 10. Okay. S plus 5 over 4. Okay. So this one. If 1 over S minus A, it will be exponent 80. If S plus A, then it will be exponent minus 80. Okay. So here will be 10 exponent minus 5 over 4 T. Okay. Okay, we simplify again. Kita pemudahkan kan. So 10, 10, so 20. 20 minus 10 exponent minus 5 over 4T. You times with HT. Okay. Okay, ada soalan? Do you have any question? Tak ada.
Ada.
Doktor nak
Tak
tengok
ada,
part
okay.
partial fraction doktor.
Mana?
Partial fraction kat bawah sekali.
Oh, bawah sekali. Okay dah.
Doktor,
Ni saya.
yang HT tu dia kena macam tu je ke jawapan dia atau kena darab like macam 20 HT lepas tu negatif 10 eksponen negatif
Tak boleh, tak
54.
boleh.
Tak payah.
Nak buat macam tu pun boleh. Buat kurungan macam ni pun boleh.
Okay.
Okay. Ada soalan lagi? Tak ada. Okay, tak ada, kita tengok yang bahagian B. Okay, so bahagian B. Okay, you have this circuit. Okay, plus minus R and L. Okay, you have a RL circuit. We call this one RL circuit. Okay, so 4 ohms, 2 Henry. Okay, and the VT is equals to 4 exponent minus 3 TUT. Okay, and given the initial current is I0 minus equals to 1 ampere. Okay, so dekat sini sama juga, you have to solve the IT and VT. Okay, you have to find the I and V in time domain. Okay, so stepnya masih sama. Okay, using the same step. Okay, you convert this time domain signal to the frequency domain signal. Okay. Okay. So this one, okay, you have the, okay, so this VT, okay, you convert to frequency domain, okay, VT equals to, you find the Laplace for 4 exponent minus 3t ut. Okay, so this one will be Vs equals to, you find the Laplace for 4 exponent minus 3t ut. What did you get?
4 1 S plus 3.
Okay, so you have 4s plus 3. Okay. Okay, this is for this one. Okay, and then you have the R. Okay, so R, okay, if you change to this one, you will get I S R. Betul? Right. Here. Okay, RIS. Okay. So what is R? R is 4. So 4 I S. Okay. And then here you have the inductor. Okay. So for inductor, we know that V T VLT equals to L DIT over DT. Okay, then this one will be, if you Laplace this one, it will be Vs equals to L S IS minus I0. Okay, and equals to L IS minus L I0. Okay, so here you have, okay, LIS. So what is L? L is 2. So 2 IS. Here you have plus minus. Okay. This one is L is 2. So minus 2. I0 minus is 1. So minus 2. Okay. Okay, ada soalan berkenaan ni?
Madam boleh ulang balik yang part negatif 2 dekat voltage tu.
Yang ni ke yang ini?
Yang tu.
Ni.
Yang tadi pun okey.
Ni.
Ah.
Okay. Okay. So for inductor, okay, if you want to find the voltage for inductor, you have to differentiate the current. Okay. So VLT is equals to L dit over dt. Okay. And then you Laplace the whole equation here. Okay. You will get Vs equals to L. If you Laplace I, this one we call, sometimes we call it I prime t. Okay. If you differentiate this one, you will get SIS minus I0. Okay. And then you times everything with L, then you get Vs equals to LIS minus LI0. Okay. And the value for L is 2. L equals to 2 Henry here. Okay. So you gantikan 2 here, you will get 2 IS minus 2 times with I0 is 1. Okay. Then you get here is 2 IS, here is minus 2. Okay.
Okey, madam. Faham?
So doktor, yang VS tu 4 over S plus 3 doktor.
No, this one is a VLS. VLS.
Okay.
This one voltage for inductor.
So yang VS yang doktor buat yang depan sekali tu, yang tu untuk apa doktor?
This one is a given the VT is 4 exponent minus ST, right? Dia punya dia punya apa tu dekat sini dia kata source of this circuit. The source of this circuit. Okay. VT equals to this one. So you Laplacekan this one, you dapat yang ni.
So yang UT tu apa jadi doktor? UT.
UT tu tak ada apa. Okay, kalau you tengok dekat sini. Tak ada. Because UT is a unity. Is a unit step. Okay, it just want macam ni saya nak cakap if any signal that we times with UT, that mean our signal start from 0. Okay.
Madam nak tanya lagi satu.
Ya, saya.
Dekat voltage yang dekat inductor tu, tak boleh letak negatif 2 je sebab itu dalam kurungan kan 1.
Tadi negatif 2 saja.
Boleh kan? Okey. Lepas tu, okey. Ni inductor, dia akan ada memang akan ada 2 source Kalau capacitor tadi 1.
Capacitor ni tadi sebab dia tak ada source given. Dia cuma ada capacitor dengan mana tadi sekat tadi? Capacitor dengan resistor sahaja. Dia tak ada source lain.
Okay.
Okay. But this one you have a source here kan? This one. Okay?
Okay, faham doktor.
Okay. So this is your transform circuit.
Madam,
Ya, saya.
nak tanya untuk yang voltage inductor kan yang dekat L darab dengan SIS kan?
Kat mana?
Dekat yang cari voltage inductor punya Laplace.
Ni kan okay.
Ya. Kan kalau kita darabkan L tu dengan yang dalam, so LIS S-nya tak ada ke?
Ni S-nya. Oh, sorry, S-nya. S-nya ada. Okay, thank you.
Okay.
S-nya tak hilang, ada. Okay, sekejap 2 SIS. Okay. Okay. Okay, ada soalan lagi? Ada soalan lagi?
Ada doktor.
Okay, kalau tak ada. Okay, so next step kita analyze this circuit using KVL. Okay. Okay, so kalau you analyze this one, what you get? Okay. Okay.
Negative
And
4 over
negative 4 over
S plus 3
S plus 3
plus 4IS
plus 4IS
plus 2SIS
plus 2SIS
minus 2
minus 2
equals 0.
equals to 0. Okay. Lepas tu, you kumpulkan IS. Okay, so bila kumpulkan IS, mana? So, you akan ada 2S, betul? Tambah 4, 2S plus 4. Okay. Equals to?
2 plus
4,
over S plus 3
4 over S plus 3
plus 2.
plus 2. Okay. And then IS equals to 4 plus 4 plus
S over 3
4 over S plus 3 plus 2 divide by
plus 4. S plus 4. 2S plus 4.
2S plus 4. Okay. Okay, simplify this one. So 4, macam ni nak simplify.
Over S
4
plus 3
over S plus 3
tambah 2
tambah 2
darab 2S plus 4.
macam ni eh?
Darab semua doktor.
Okay, lepas tu sama juga dengan
8S plus 16
panjang sangat tak? Sama juga dengan 8S eh?
nak expand kan doktor?
Ikut awak semua. Saya follow. You all yang nak jawab exam. Okay. So, sama juga dengan
8S tambah 16 per S plus 3 tambah 8S plus 16.
4 kan? 4S
4S
tambah
tambah
16.
8.
Okay, lepas tu?
8 doktor.
Ha?
8.
Okay. Okay, lepas tu? Okay. Lepas tu?
Kena Laplace kan doktor?
Macam mana?
Laplace IS
Mana yang lain diam je?
Macam silap je dia permudahkan.
Yang lain macam mana?
Kalau dua atas tu kita dapatkan S plus 3 tak boleh? Sama kan? Lepas tu bawah.
Yang mana? Yang ni?
Atas tu.
Yang ni?
Ha.
Macam ni?
Ya.
Ya. Lepas tu
So dapat 2S tambah
10
10
over
S tambah 3.
Ha.
Okey, lepas tu darabkan dengan yang ni. Betul?
Bahagi.
Bahagi bahagi.
Bahagi. So
2S plus 10. S kurungan
macam mana ni? Bahagi
2S plus
Ni.
4.
2S plus 4.
Okey, lepas tu Lepas tu Lepas tu you keluarkan 2S tambah 5. Betul? Bagi S tambah 3. Sini you keluarkan 2S tambah 2. Right? 2 cancel. Betul?
Betul.
Okay. So sama juga dengan S tambah 5 per S tambah 3 S tambah 2. Betul?
Betul.
Okay, lepas tu
Partial fraction.
Partial fraction.
so S tambah 5. Betul ke? Sama juga dengan pergi tidur. Okay. Okay. Betul tak ni?
Betul.
Okay, so sama juga dengan
A
S
S tambah 2.
plus 2 plus B S plus 3 sama juga S plus 5. Okay, so S minus 2. Minus 2 jadi A kosong, B
Kosong.
B minus
Equal
Jadi
to 3.
B kan? B equals to 3. Okay, and then S equals to minus 3. Then minus A equals to 2. Betul? 2. A equals to minus 2. Betul? Betul? Betul tak?
Betul.
Betul Okay. So jadi IS. Okay, you have a IS equals to A is minus 2 over S plus 3 plus with 3 over S plus 2. Okay. This one is IS. Okay. Okay, so IT, okay, is the inverse of IS, okay, equals to inverse for minus 2 over S plus 3 plus with inverse 3 over S plus 2. Okay, so 2 keluarkan, 3 keluarkan. Okay, you have a minus 2 okay, inverse 1 over s plus 3 plus with 3 inverse of 1 over s plus 2. Okay, so inverse for is it. Okay, equals to minus 2. Okay, inverse for 1 over s plus 3 is exponent minus 3t. Okay, and then a plus with 3. Okay, inverse for 1 over s plus 2 is exponent minus 2t. HT. Betul? This is your IT. Okay? Okay? Faham tak?
Okay, madam.
Okay. Okay, so tak habis lagi because soalan dia, okay, the question asks you to find I and V. Okay, so now kita cari V. Okay, so V, okay, we use these equations. V LS equals to this one. Okay. So you have here is Vs equals to, okay, LSIS minus Li0. Okay. So L is, apa nilai L awak tadi?
2.
2. So L is 2S IS minus 2. I0 1 kan? Okay. So IS here, okay, is from here. Okay. You take a IS from here. Okay. So you will have 2S, okay, times with IS. And mana IS awak tadi? Okay. Minus 2 over S plus 3. Okay, plus with 3s plus 2, then minus 2. Okay. Okay, so and then you darabkan, you will get minus 4s over s plus 3 plus with
CS.
6s over s plus 2. Okay, minus with 2.
2.
Okay. Okay, so pemudahkan this one. Okay, simplify this equation. Okay, simplify this one. You will get okay. So minus 4 times is s plus 2 plus 6s. Sorry, s plus 3 minus 2. Okay, betul? Betul tak?
Betul,
Betul.
madam.
Okay. Okay, so kita kembangkan satu-satu. Okay, betulkan saya sebab saya banyak-banyak ni nanti selalu salah ni. So this one will be minus 4s square, betul? Minus 8s, okay. And then plus with 6s square, plus with 18s, okay. And this one saya darab siap-siap dulu s square plus 5s plus 6 and times with 2. Betul tak ni? So minus 2s square minus 10s minus 12. Bahagikan dengan s plus 3, s plus 2. Betul tak?
Betul.
Betul Okay, s kuasa 2, s kuasa 2, s kuasa 2. Minus 4 plus 6
Kosong.
minus 2. Okay, so kosong, cancel. Cancel. Okay, now s, s, s. Minus 8 plus 18. So 10 minus 10.
Kosong.
So kosong juga. Okay, so sekarang tinggal minus 12. Okay, so we have minus 12 over s plus 3, s plus 2. Okay. Okay. Okay tak?
Okey, doktor.
Okey.
Okay, so ini Vs equals to minus 12 over s plus 3, s plus 2. Okay. Okay, so kita nak dapatkan, we want to find the time domain signal. So inverse Vs, okay. And then you inverse this one also. Okay. Okay. So to find inverse here, you have to use partial fraction dulu. Okay, nanti kejap mama kelas nanti mama beri kat Afi. Okay. So this one, okay, awak pakai pecahan separa. Okay, so you have minus 12 over s plus 3, s plus 2 sama juga dengan equals to a over s plus 3 plus b over s plus 2. Betul? Betul Okay, so you have a s plus 2 plus b s plus 3 equals to minus 12. Okay. Okay, next is if your s equals to minus 3, b equals to 0, and minus a equals to minus 12, a equals to 12. Betul? If s equals to minus 2, a equals to 0, b equals to
Negative 12.
b equals to negative 12. Okay. So you masukkan balik dekat sini. So you have a minus 12 over, minus 12 pula. A 12 kan? So 12 over s plus 3 minus 12 over s plus 2. Okay. So inverse Laplace of Vs equals to inverse Laplace of A is 12 per S tambah 3 minus 12 over S plus 2. Betul? Okay. Okay, so inverse for Vs is Vt. So equals to 12. Inverse for 1 over S plus 3 is exponent minus 3t minus 12 exponent minus 2t times with ht. Okay. Ada soalan?
Tak ada.
Tak ada. Senang kan? Senang kan?
Boleh doktor.
Doktor, kalau soalan macam ni berapa markah?
Soalan macam ni berapa markah Soalan macam ni biasanya dalam 15, 13 hingga 15.
Lepas tu kan doktor, dalam
Ya.
satu circuit tu dia memang akan ada capacitor saja dengan resistor atau dia boleh gabung semua?
Dia boleh gabung semua.
Gabung
Dia
tiga
boleh
tu lah.
jadi RLC, dia boleh jadi RC, dia boleh jadi LC, dia boleh jadi RL.
Okay.
So kalau you faham dia punya yang ini, yang mana tadi, yang first kali saya tunjuk. Okay, yang ini kan. Okay. So kalau you tahu yang ini, so you apa-apa circuit you boleh solve. Okay, so you know that from R, kalau you ada R, you nak tukar, you want to change to frequency domain, okay, it will be R times with IS. Okay, if you have an inductor, okay, you know that inductor, okay, kita boleh dapatkan voltage, okay, through this inductor, okay, by differentiate the current. Okay, lepas tu kita dapatkan Laplace untuk equation ni. Okay, so Laplace untuk equation ni adalah yang ini. Okay, kalau kita transformkan dalam circuit, kita dapat macam ni. We have L, S, I, S, and then kita ada minus L, I, 0. Okay, and this is capacitor. So for capacitor, usually kita dapatkan dia punya current I. Okay, and then kalau you tukarkan ke Laplace, you will get in a current is IS equals to this one. Kalau you dapatkan dalam voltage, you will get I over S, IS over CS plus with V naught. Okay, the initial value for voltage divided by S. This one. And this is the equivalent circuit. Okay, so make sure if you get any question like this, so what you need to do is you have to transform first from time to S using this transformation. Okay, so you transform everything, okay, and also you draw the new transform circuit, okay, like this, okay, and then you make the analysis using KCL or KVL, depends on the question. Okay, from the analysis, okay, then baru you boleh dapatkan dia punya current or voltage. Usually selalunya kita akan dapatkan current dulu. Okay, we calculate the current and then kita boleh dapatkan dia punya voltage. Okay, to get the current and voltage, okay, in a Laplace, okay, you get in the S domain, okay, and then you use the inverse to get the time domain. Same goes to the voltage, okay. You analyze in S domain and then you use the inverse to get the VT. Okay. Okay. Ada soalan lain tak? Nak tanya saya? I'm not going to discuss about the double loop, okay?
Double loop ada keluar madam.
Double loop tak ada.
Okay. Madam ada contoh untuk RCL. Contohlah kan kalau nak cari RCL tu kena settle semualah baru dapat IS.
Ya, you kena transform dulu circuit ke dalam S domain. Okay. Lepas tu baru you boleh buat analysis.
Okay.
Okay. You all punya final senang je. Okay, so saya stop record dulu. Stop presenting. Stop recording.